Okay, to start off today, I want you to picture something. Imagine dramatic aerial footage of massive, utility-scale power transmission grids stretching out across entire continents. Think about colossal electrical substations humming with power, and these incredibly thick, heavily engineered cables being laid down across our oceans. This is the hardware that literally powers human civilization. Welcome to today's Explainer, where we're going to dig deep into the sustainability of our global energy infrastructure.
Now, before we can even begin to measure the environmental and social impact of this industry, we really have to wrap our heads around its sheer physical magnitude. We're talking about the hidden backbone of modern society here. Every single time you flip a light switch, plug in an electric vehicle, or stream data from a massive server farm, you are directly relying on high-voltage testing bays, towering power transformers, and literally millions of miles of transmission cables.
So for this explainer, we're zeroing in on a very specific set of companies. Under the official classification, these are the entities that make up the electrical and electronic equipment industry. These are the massive global manufacturers operating high-voltage bays, building everything from industrial-grade coils and switchboards to the advanced hardware required for renewable energy grids. You see, they don't just assemble consumer electronics, they manufacture the foundational equipment that makes global energy transmission even possible.
And what you're looking at right now brilliantly illustrates what you might call the industry DNA. This is the SASB Sustainability Accounting Standard for this exact sector. Instead of relying on, vague corporate promises about going green, investors and regulators use these highly specific standardized metrics to measure the true footprint required to build our energy infrastructure. It's a rigorous framework. It tracks everything from the energy used right there on the factory floor all the way to the raw materials dug out of the earth.
Here's how we're going to break it all down today. First, the global energy backbone. Second, manufacturing the grid. Third, safety and life cycle. Fourth, sourcing critical materials. And finally, ensuring business ethics.
All right, let's jump right into Section 1, the global energy backbone. We're defining the scope of modern energy delivery.
It's really important to remember that these companies generally aren't making the sleek consumer gadgets you buy at the electronics store. No, they're manufacturing the heavy-duty electrical power equipment that makes everything else work. We're looking at traditional power generation and transmission equipment, advanced automation controls, highly sensitive measurement instruments, and massive HVAC systems. And they operate on a truly global scale. The equipment they roll off the line in one country often ends up powering the grid of another completely different country.
Moving right along to Section 2, manufacturing the grid. Here, we're tracking energy management and hazardous waste.
Inside the factory, under the SASB framework, we find a really fascinating comparison. We're looking at a manufacturer's reliance on standard purchased grid electricity versus their direct use of clean renewable energy. This is absolutely vital because, and here's the irony, the industry that builds the electrical grid is itself incredibly energy intensive.
To track this, companies have to disclose their total energy consumed in gigajoules, which reveals their exact energy mix. Investors want to see precisely what percentage comes from traditional grid power, what comes from direct fuel usage, and most importantly, what comes from renewables like geothermal, wind, solar, and hydro. And they are super strict about this. If a company generates renewable energy on-site but then turns around and sells those renewable energy certificates to someone else, nope, they are not allowed to count it as renewable for their own metric. It's all about uncompromising transparency.
But wait, energy is really only half the manufacturing story. Building this kind of heavy-duty equipment generates some pretty intense industrial byproducts. Which brings us to hazardous waste management. We are talking about heavy metals and wastewater treatment sludge generated right there on the assembly lines. Under the standards, companies must track the total weight of this hazardous waste in metric tons.
And here is where it gets really interesting. The definition of recycled is incredibly strict. SASB explicitly states that simply incinerating waste to generate energy recovery does not count as recycling. Companies have to track the true percentage of waste that is actually reused, reclaimed, or remanufactured. It forces manufacturers to pursue genuine long-term waste reduction, rather than just burning the problem away.
Okay, let's pivot to Section 3, safety and life cycle, protecting the grid and the consumer.
Because we're dealing with high-voltage equipment, malfunctioning gear can lead to severe, cascading risks, including devastating electrical fires. So the standards track product safety by requiring companies to disclose the number of recalls issued, and they separate voluntary recalls from those mandated by regulators, along with the total units affected. Even more critically, they have to report the exact monetary losses from legal proceedings associated with product safety. It literally turns safety from a theoretical concept into a hard, measurable financial reality.
And for product lifecycle management, there's another fascinating layer here. Manufacturers must disclose the percentage of their revenue tied to products that contain specific, restricted chemical substances. They use a standard called IEC 62474 to track this. The whole point is to push companies to design products that exclude harmful materials right from day one. That minimizes environmental hazards when that equipment eventually reaches the end of its decades-long lifespan. It's not all doom and gloom and risk mitigation, though. There's a massive opportunity here, too. On the positive side of the life cycle, companies actually track their revenue generated specifically from energy efficiency and renewable energy-related products. This brilliantly illustrates how these manufacturers are actively helping to modernize the grid. We're talking about smart grid technologies, advanced low-loss transformers, and the complex interconnection systems that allow solar and wind farms to actually feed their power into our established infrastructure. Next up is Section 4, Sourcing Critical Materials, Navigating Supply Chain Risks, and Geopolitics. You see, these materials are absolutely essential to manufacture electrical equipment. You literally cannot build advanced energy delivery systems without elements like cobalt, gallium, tungsten, or rare earth elements like neodymium and yttrium. The problem? These materials face intense risks of supply restrictions. They're often concentrated in just a handful of countries, which exposes this entire industry to massive geopolitical uncertainty and volatile price swings. So the crucial point here is how companies strategically mitigate these supply risks. Investors want to know, are they diversifying their suppliers? Are they engineering alternative materials? Are they investing heavily in recycling technologies? But here's the catch. Companies have to disclose how they manage these risks without giving away their highly confidential competitive trade secrets. It's honestly a massive balancing act.
Finally, Section 5, Ensuring Business Ethics, Governance Across the Globe.
Because these entities operate globally, they're constantly navigating regions with wildly varying levels of legal enforcement. Naturally, this exposes them to immense regulatory scrutiny. So having robust ethics policies isn't just about good PR anymore. It is a hard financial metric. The standards demand total transparency on how companies assess corruption and bribery risks, and not just within their own walls, but throughout their entire network of contractors and joint venture partners.
At the end of the day, investors want to see exactly how much money a company loses to legal proceedings related to unethical practices. We are looking at fines for price fixing, exclusivity contracts, patent misuse, and even settlements for bribery. Companies must disclose the total monetary losses and, crucially, they have to explain the specific corrective actions they've taken to ensure it never happens again. It's really all about proving structural integrity at the highest corporate level.
Which brings us to the end of our explainer. When we look at the immense scale of the raw materials being mined, the massive amounts of energy consumed on factory floors, and the vast global grids currently being constructed, it leaves us with one critical question. As our demand for electricity grows, can the infrastructure powering our world become truly sustainable? The data we choose to track today is exactly what will determine the reality of our grid tomorrow. Thanks so much for joining me on this deep dive into the hidden systems that power our lives.